All right, so after you have the empirical formula, we have to remember that there is a multiplier that exists between the empirical formula and the molecular formula. Remember, the empirical formula is the simplest whole number ratio, but the molecular formula, there's a multiplier between them. Now, it might be that the empirical formula and the molecular formula are the exact same, all right? So that's always a possibility, like H2O, water, right? You can't get simpler than water, H2O. You can't get a simpler chemical formula than water, and that is also the molecular formula. Okay, so that's always a possibility. But if the empirical formula is not the molecular formula, the way we determine this is we have to be given information about the molecular mass of the compound. Once we know the molecular mass, then we can determine the empirical mass. Okay, so they never were going to give us the empirical mass, but we can always have the empirical formula, right? And this same relationship between the empirical formula and the molecular formula, right? So for our glucose example, the molecular formula is C6H12O6, and the empirical formula is CH2O. Well, just like we said that there was a multiplier here, which is, we'll call it N, it's equal to 6. Here, there's some number that you multiply all the subscript values by here, and you'll get the molecular formula. Well, that same number, same multiplier, exists between not the empirical formula, but the empirical mass and the molecular mass. All right? So if you know the multiplier here for the empirical formula to the molecular formula, then we can also identify the multiplier here to the empirical mass and the molecular mass. It has to be 6 as well. To identify the empirical mass, right, we just take the mass of this chemical formula here, which is our 30. That's what they're showing on this slide here. And then our molecular mass here would be given to us 180, or if we knew this and we knew that, we could find that. Okay? So, just like there is a multiplier between the empirical formula and the molecular formula, there's a multiplier between the empirical mass and the molecular mass. Okay? So here's an example. If we have a chemical, hydrazine has a chemical formula NH2, and we're told here that its molecular mass is 32. What is its molecular formula? Okay? So, 32 is the molecular mass. Molecular mass, 32. Empirical mass, we haven't been provided necessarily. The empirical formula, do you know the empirical formula?
NH2.
That's right. Empirical formula, NH2. And what they're asking us for is the molecular formula. So we need to know that multiplier. But we know that the same multiplier exists here. Well, too bad we don't know the empirical mass, because then we could just take 32 divided by the empirical mass, and that would be our multiplier. Follow that?
Yeah, I see that. We can get the empirical mass, though, can't we?
We can. How do we get it?
Just the mass of the empirical formula.
That's right. So nitrogen, do you remember what nitrogen is?
14.
Hydrogen?
1 each, so that's 16.
All right. So the empirical mass is 16. The molecular mass, we're told, is 32. So what does that tell us?
Tells us that our multiplier is 2, so the molecular formula is just N2H4.
Very good. Excellent. So because this multiplier, the N value here was 2, it's going to be the same value there, and that's how we get our molecular formula from our empirical formula. Excellent. All right. So here's another one. If we're told that a substance is 35% nitrogen, 5.05% hydrogen, and 59.96% oxygen, can we get the empirical formula?
Well, I could last week, but I can't remember now.
All right, well, let's go through this together then, okay? If you know at home, then you push pause and you practice it, and then come back and we'll see if you got it right. Okay. So, what do we do with these percentages?
That's what I can't remember.
Well, they're percentages in terms of moles or in terms of grams?
Oh, grams?
That's right. Mass percentage is always in terms of grams. And that's, something we do have to remember. We want to remember because then we can essentially say that our sample, if we had a 100-gram sample, we can just assume we have a 100-gram sample, will be 35 grams nitrogen, right? 5.05 grams hydrogen, and 59.96 grams oxygen. Now, how does that help us with the empirical formula?
I know this. The empirical formula is the mole ratio of the atoms in the compound.
That's right, the molar ratio. So, if I take these masses here and convert them to their moles of the compounds, right? Then I can identify the moles of each of these compounds, right? 14 grams for every 1 mole. Do you know where we get this 14?
That's what's on the periodic table. That's what that value is. It's on the periodic table. Can you see this? Show me the periodic table.
Yeah.
Yeah, see underneath the nitrogen, the 14 there, the units on that 14 are how many grams you need to get 1 mole.
Very good. So if I'm converting from gram to mole, I divide by my 14. For hydrogen, it's pretty much 1 gram for every, 1 gram down here for every mole of hydrogen. This is nitrogen, moles of nitrogen, grams of oxygen. Okay, very good. So 35 divided by our 14, 2.5. I can put that in there for the moles of nitrogen. This is going to be 5.05, essentially the same because it's 1-to-1 ratio. And then our 59.6, or 0.96 divided by 16 is 3.745. Okay, now what do I do with those values? 2.5, 5.05, 3.745.
Those are moles, right?
Yeah, that's all moles of the elements. And so I can use that for my empirical formula, right?
Yeah.
Okay, good. So I can go N 2.5, H 5.05, O 3.745. Does that make sense?
Yeah, that makes sense.
Okay, very good. So now we're going to find out how many, or what the whole number ratio is, not just these fraction ratios. How do we do that?
You divide by the smallest number.
That's right. So 2.5, 2.5, and 2.5. Very good. So that makes nitrogen, the whole number for the nitrogen there is going to be 1. 5.05 divided by 2.5, that's, whoops, got to start over here. So I'm going to, okay, here we go. Nitrogen is, oops, just blowing away. Nitrogen is 1. Oxygen is 2. Sorry, did it again. Nitrogen is 1. Hydrogen is 2. And oxygen is our 3.745 divided by our 2.5, which is 1.5. Okay, so what do I have to do to improve that ratio there?
I think you have to multiply everything by 2.
Yeah, how do we know that? How do we know to multiply it by 2?
Because the 1.5 needs to be a whole number.
Very good. 1.5 needs to be a whole number. So I can multiply that by 2 and make that 3. This becomes a 6, and that becomes a 2. Very good. That is then my empirical formula, N2H4O3. Now, if I want to determine the molecular formula, I need to have information about the molecular mass. But after I have the information about the molecular mass, how do I go about getting the molecular formula? All right. So I'm going to have, again, my empirical formula, N2, H4O3, right? And I'm going to need to go to my molecular formula. So this is my empirical formula, and I want to go to my molecular formula. Okay, now to do that, I'm going to need to know the relationship between the empirical mass and the molecular mass. Because whatever that relationship is, that ratio, in terms of numbers, is the same ratio for the numbers that the multiplier we used on these subscripts to get the molecular formula. Okay? So, where do we get the empirical mass?
They didn't give us that. I think they needed to give us that.
Well, we have the empirical formula.
Oh, yeah, the empirical formula. Just add that up. That's the empirical mass.
Very good. So N2, 14 plus 2, 28, plus 4, 32, plus our 46. Is that 80?
Yeah, that is.
So what does that mean? If the empirical mass is 80 and the molecular mass is 80, right? Where do we get that molecular mass?
They gave us that.
That's right. So what does that mean?
That means that the empirical formula is the same as the molecular formula.
Very good, because this N value here is 1, so N equals 1 here also, and this is N2H4O3. So the empirical mass in this case is the molecular mass. Sorry, the empirical formula is the molecular formula because the empirical mass is the molecular mass. All right, very good. So here we have a couple of different problems that now, in this case, we're given percentage of material, but we need to find the presence of a third element, What are you talking